Hi folks, we're going to take a look at question 4D on the additional questions for the Unit 1 assignment. So here they're asking us to solve this polynomial inequality. So I'm just going to go through the algorithm that we have for solving a polynomial inequality. So step 1 is to get all terms to one side and have 0 on the other side. So I'll start doing that. So I'll keep the x cubed here. Always like to keep a positive leading coefficient if I can. Bring over the 3x squared, so it's going to be minus 2x squared. Bring over that, so negative 21 plus 2 is going to be negative 19x, and then 20 minus 1 is 20. All right, so from this point forward, our next part of the process is to factor the left-hand side. So our end goal is to sketch a quick graph of this polynomial once we have it in factored form, and then from there I can read off that graph where it's going to be less than or equal to 0. So I take a quick look and I can see that grouping is not going to work in this question. So we'll start by going through our factor theorem process. So I'll call this P at X. So we check P at 1 and let's check that out. 1 minus 2 is negative 1, minus 19 is negative 20, plus 20, it's equal to 0. So we got lucky right on our first try. All right, so let's divide out x minus 1, and then we'll just be left with a quadratic, which we can, of course, work with. So here, that's 1, and our coefficients are 1, negative 2, negative 19, and 20. So 1, 1, this is going to be negative 1. This is going to be negative 20, and then lastly, negative 20, which adds up to 0. So we likely didn't make a mistake if we ended up with a 0 remainder. All right, so what does this mean? It means that this expression on the left can be written as x minus 1 times this quotient here, x squared minus x minus 20. And that actually looks good for factoring nicely. Won't need the quadratic formula. So here we have x minus 1, and here we'll have 5 and 4 is going to work. So we're going to need minus 5 and plus 4. All right, so now that we've completed the algebra, we can take this information, in other words, 3 x-intercepts, and a cubic with positive leading coefficient. We can draw a quick sketch to determine where this is above or below 0. All right, so here we've got negative 4, 1, and 5. All right, here I want to include these 3 because it can be less than or equal to 0, so whatever makes them equal to 0 it will also be included, so that's why I have these filled in circles. And since it's a cubic with a positive leading coefficient, it's going to start at negative infinity and eventually end up at positive infinity. And so now I can read off the graph when this is going to be less than or equal to 0. So here the solution is going to be x an element of, well, all numbers up to and including negative 4, so negative infinity to negative 4 inclusive, and then union this interval here from 1 to 5, including the endpoints, so 1 to 5. All right, and there's our answer. So again, just to recap, I'm following my algorithm for solving polynomial algorithms. Get everything to one side, factor. Once I have it in factored form, I can then use the degree and leading coefficient and the zeros, sketch a quick graph, read the answer right off that graph. Okay, that's it for this one.